How small are atoms? Imagine a football with the size of the Earth. Let's look closer and closer. Its atoms would be smaller than this frog. Atoms are incredibly tiny, which is why we can't see them.
Yes, 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 yes.
This cooking oil is used for tempura and other fried foods. Old cooking oil is normally discarded, but it can be converted to fuel vehicles. Old cooking oil is fed into this device. Sodium hydroxide and other chemicals are added to remove the grime and make the oil suitable for use as fuel. The fumes produced by this fuel do not pollute the air as much as standard vehicle fuels.
Yes, 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 yes.
Energy can be obtained from some unexpected sources. This factory gathers up old timber from demolished houses. It produces a new form of energy from something that is difficult to dispose of. A type of alcohol known as ethanol is produced from the timber. The ethanol can be blended with petrol to fuel vehicles.
Yes, 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 yes.
How is carbon dioxide produced? Let's burn a disposable chopstick on a balance scale. The chopstick becomes lighter as it burns. Something is being produced from the chopstick. In burning, a substance called carbon combines with oxygen in the air, producing carbon dioxide.
Yes, 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 yes.
Let's try to put out an alcohol lamp. It's not easy to put out the lamplight by blowing. A glass cover is needed. Does the lamp go off because the fire touches the cover? Let's watch the process in slow motion using a high-speed camera. The fire which touched the cover continues to burn for some time. The fire is put out because the cover is put over it and the oxygen is used up.
Yes, 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 yes.
Let's see how water can become acidic. Carbon dioxide is emitted in combustion and it readily dissolves in water. Let's dissolve some. We add carbon dioxide to this plastic bottle of water, replace the lid, and give the bottle a good shake. The bottle contracts because carbon dioxide shrinks in volume when it dissolves in water. Let's see if the carbon dioxide has really dissolved by adding some lime water. The water turns milky, which indicates that it has. Let's check the pH level. It's 5.1. The water has turned acidic with the addition of carbon dioxide. Water will sometimes assume different properties when it dissolves a gas.
Yes, 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 yes.
Let's see what happens when exhaust fumes are dissolved in water. We can collect fumes by placing a bag over the car's exhaust pipe and then add water. The water has a pH level of 5.6. Giving the bag a good shake will get the exhaust fumes to dissolve in the water. Let's check the pH level again. It's 3.76, which is more acidic.
Yes, 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 yes.
Car fumes, the smoke from factories, and volcanic smoke are responsible for acid rain. When these gases are present in the atmosphere, they will dissolve in clouds and rain and turn the rain acidic. Acid rain can produce various effects. It can kill the trees in forests and eat away the concrete on motorways. Acid rain results from the dissolving of exhaust fumes and other gases present in the air.
Yes, 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 yes.
The Forestry and Forest Products Research Institute in Japan have let us visit their facility at the foot of Mount Fuji, which gauges the amount of carbon dioxide absorbed by the surrounding forest. It consists of a 32-meter tower, which monitors the wind directions and carbon dioxide levels. This device gathers air and feeds it along a tube down to this hut full of instruments at the base of the tower. This machine measures the amount of carbon dioxide in the air. Information about the carbon dioxide levels, wind direction, temperatures and so on is used to calculate the amount of carbon dioxide absorbed by the surrounding forest. After a year of observation, it was found that each hectare of the surrounding forest absorbed about 14 tons of carbon dioxide.
Yes, 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 yes.
A train glides past, but it's a bit different from your normal train. Can you tell the difference? The pantograph or frame on the roof hasn't been extended to come in contact with the overhead wires. The electricity propelling this train doesn't come from the overhead wires, but from this generator on board. This generator has fuel cells. Fuel cells are a clean source of energy that does not emit any carbon dioxide.
Yes, 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 yes.
Over-polluted, overcrowded, and overfished. The world's oceans have been exploited by humans for centuries. And this new map reveals the extent of the damage for the first time. It's colour-coded. The large stretches of orange show where our impact has been high. That covers more than 40% of the oceans across the Atlantic, the Pacific and beyond. Light blue or green means the impact is low. Just 4% falls into this category, with the polar regions least affected. Worst of all, in red, are the areas where the most damage has been done. And the state of British waters is all too clear, with large swathes of red around much of the coast. The impact of decades of fishing, shipping and tourism around Britain's shores has been huge, and now the scientists say that these waters here in the English Channel and the North Sea could be more badly affected by humans than just about anywhere else on the globe. For a country rich in oil and gas, that's not a surprise. Offshore exploration was among 17 human activities factored into the new study. As a heavily populated island nation, Britain was bound to come out badly.
It's important for the European economy, not just for Britain, that this is a maritime area with a lot of maritime trade, but inevitably that carries risks, as we've seen over 30 years with shipwrecks from the Torrey Canyon through to the Napoli.
And around the globe, the new study found no square kilometre of ocean untouched by humans.
We found in our results that every single spot on the planet has been affected, at least to some degree, by human activities. And this was phenomenal. It's very surprising.
And climate change could make things worse. Here scientists are monitoring the water temperature off the Devon coast. It's already rising. But tests of water quality show many industrial pollutants are declining. And some experts remain positive.
If you go out there and you look at what's on the seashore or under the seabed, there's still some fantastic environments down there that look beautiful, that I want to go diving in, that I want to go and look along the seashore. So I think it's not all doom and gloom.
Sea life is still flourishing in places, but scientists agree conservation measures are needed urgently to protect it for future generations. Christine McGurty, BBC News.
Yes, 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 yes.
In California, scientists were focusing on trying to create a new element heavier than uranium.
The key to this was a machine called a cyclotron, which gave rise to this giant machine, a synchrotron. Both machines operate on the same principle. They use huge magnets to steer charged atoms round and round, faster and faster. The magnets are so powerful that if one of them was switched on, it could rip a sledgehammer straight out of my hands. Now, the way to make a new element is to increase the number of protons in a nucleus of an existing element. And in a cyclotron, the way this was done was that when the charged atoms reached 1/10 of the speed of light, they were steered and smashed into a metal target with the potential to create a new element.
Finally, man's dream of creating a building block from beyond the end of the periodic table was about to be realized.
American physicists Edwin Macmillan and Philip Abelson blasted uranium with a beam of particles to create element 93.
They named it Neptunium, the first element heavier than uranium to be created by man. Chemists were once limited to using the elements nature provided. Now, science breached this frontier, creating synthetic elements. And with this new power would come new dilemmas.
Yes, 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 yes.
Copper is a lustrous metal, essential for life. It fueled the move out of the Stone Age into the Bronze Age. Copper nuggets can be found on the Earth's surface. but it usually needs to be extracted from ores. And copper compounds run in the veins of some animals. The blood of the octopus is blue, along with snails and spiders.
Yes, 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 yes.